Now see guys, we are left with the incomplete properties of mechanical properties of materials. Here we can see the further properties of material, that is comes under the mechanical properties. Okay, see guys, what it is written here, hardness. Please see. Now what do you mean by hardness is? See guys, hardness is defined as the ability of a material to resist to scratching, abrasion, cutting or penetration by harder bodies. Please see guys, here you can see one image which is hammering one plate, okay, by one by one AG component. Okay, you can see guys, hardness is defined as the ability of a material to resist to scratching, abrasion, cutting or penetration by harder bodies. Okay, the material which can resist penetration, abrasion, cutting, okay, scratching is known as your hardness. Okay, if you found that some metals are very difficult to drilled, okay, very difficult to drill, so that materials term as a harder bodies or harder materials. Okay, so examples of hard materials are diamond, boron carbide, tempered steel, granite, concrete, high carbon steels. All these materials are very harder. Okay, all these materials possesses hardness. So hardness means nothing but the hardness is defined as the ability of a material to resist scratching, abrasion, cutting or penetration. Next is, see guys, in this slide toughness is there. You can see two properties, that is toughness is there, and here is brittleness. Okay, toughness and brittleness. Now what do you mean by toughness is? And we are seeing a mechanical properties of material. What we are going to see? Mechanical properties of metals. See, it is the amount of energy a material can absorb before fracture when subjected to shock loads. See guys, it is the amount of energy a material can absorb before fracture when subjected to shock loads. Okay, see guys, shock loading means what? Shock loading means nothing but your impact loading. Okay, it is the amount of energy that a material can absorb before fracture. So before fracture, how much amount of energy your material absorb when subject to shock loads are termed as toughness. Okay, then tough materials means what? See guys, what are the example of tough materials? It is stainless steels, titanium alloys and aluminium. All these are the tough material. Okay, see guys, you can see this image. One showing tough and another showing brittleness. So toughness means what? If I am talking about this diagram, that is toughness, if I hammer to this rod, then it is not what breaking, it is bending but not breaking, because it has toughness. It is tough, not brittle. Please see, it is tough, not brittle. And if we seen this image which is showing us that is brittleness, so if I hammer this rod, then what happens? That rod broken down instead of bending. So why it is broken down? Because it is brittle material. Okay, so this is the basic difference in toughness and brittleness. Okay, so see, we have seen toughness, that it is the amount of energy of a material that can absorb before fracture when subjected to shock loads. And what do you mean by brittleness is, it is the property of breaking into pieces. See guys, it is the property of breaking into pieces without much permanent distortion. See guys, it is the property of breaking into pieces without much permanent distortion. So for justifying this brittleness, I am giving you one example of material which is termed as glass. Glass is the most brittle material. If you throw glass from certain height, you can see your glass is broken down or breaking down into so many pieces, because it is a brittle material. Brittle material is extremely hard material. It is not tough. Okay, and in this image you can clearly get to see that what do you mean by toughness and what do you mean by brittleness is. So what are the examples of brittle materials? Please see here. That is glass, coal, concrete, diamond, bone, cast iron, ceramic and concrete. So all these are what? All these are the examples of brittle materials. Okay, so I think this content is helpful to understand what do you mean by toughness and what do you mean by brittleness is. See guys, here we are starting with the mechanical properties, that is resilience, stiffness. See guys, what do you mean by resilience is? Very rare property this is, and very few students have known about these properties, which comes under the mechanical properties of material, that is resilience. So resilience is the capacity of a material to absorb energy elastically. See guys, what it is tells us, resilience is the capacity of material to absorb energy elastically. On removal of the load, the energy stored is given off exactly as in spring when the load is removed. So if you observe the spring phenomena, if you loaded the spring, then it will just compressed, and as soon as you release that load, your spring will be regain its original shape and size. Okay, so resilience means what? Okay, it is quite sound like elasticity, but it is not elasticity. It is little bit different than elasticity. So resilience means, resilience is the capacity of a material to absorb energy elastically. Okay, it is absorbing elastically energy. It is absorbing the energy elastically, and on removal of the load, the energy stored is given back to that load, just like your spring. Okay, this is called as resilience. Now what the stiffness is? Now stiffness is the resistance offered by metal to elastic deformation is called stiffness. The resistance offered by metal, okay, see, the resistance offered by metal to elastic deformation. Okay, suppose your metal is elastically deformed, which means your metal is regained its original shape and size. So this stiffness is refers to plasticity. Okay, stiffness is the property which resists that elastic deformation. Okay, which resists that elastic deformation. It resists elastic deformation, and it it favors the plastic deformation. So this is called as stiffness. The next is fatigue, one of the very popular property of material. See guys, what do you know fatigue is? Let me tell you, let me give you one example first, that is what do you know fatigue is. Okay, so many times when we got bored of anything or any work, any regular work, so we need to take some break. Okay, suppose let us take an example of 1 week. Okay, at the weekend, that is yes, on Sunday, all of us have holiday. Okay, Sunday is a holiday. Why Sunday is given? Because if we continuously work from Monday to Sunday, and if there will be no holiday given to us, then what will happen? We got bored of that work, and whatever work we are going to do is not we can't do that work effectively, and we are not going to enjoy our work. So what happens? The efficiency and the result, whatever will be the result, expected result, that expected result we are not going to see, because if we are not enjoying our work, if we are not doing our work properly, then what it means, the quality of work has been fall down. Okay, so fatigue is refers to that. Okay, if we are repeatedly doing something, and because of that repetition, if anything or any material got fell down, so that failure is termed as fatigue failure. Okay, so see, I have just given you example to understand what the fatigue is. So see what do you mean by actually fatigue is. See guys, when subjected to fluctuating or repeated loads, fluctuating means repeated loads, when subjected to fluctuating or repeated loads, the material tends to develop a characteristic behavior. See guys, whenever your material is subjected to repeated loads, at that time your material tends to develop a characteristic behavior which is different than that under steady load. Okay, if your material is subjected to repeated load, then at that time the material which is subjected to repeated load is develop one characteristics which is exactly different when it is subjected to steady load. This behavior is called as a fatigue. Now fatigue resistance is the resistance offered by metal when subjected to cyclic loading, that is continuously reversing loads. Okay, so if anything, the failure which occurs by repeatedly acting load is termed as fatigue failure. If just take an example of your hammer. Okay, if you hammer any metal repeatedly, and suppose with the help of that hammer or by your hammering, if that material got fell down, it means that material fails because of fatigue load, or that material follow fatigue failure. Your material follow fatigue failure. Okay, in this image, fatigue failure also known. This is origin of fatigue. Okay, from that point you can see, from that point your origin is going to be start, your phenomena of fatigue is going to be start. Okay, and it will be going on increasing continuously. You can see it will be going on increasing continuously here, and this is what fatigue zone. It will reach to the fatigue zone, and if your load is going to be acted repeatedly on your material, then finally what happens? Finally it got fatigue failure. So this is nothing but the fatigue. Now creep. Now see, now creep is again very, what we say, creep is very popular phenomena, and creep is very what we say, general phenomena of mechanical properties. Now what do you mean creep is? So first of all we should get to see this image of one tree. So this is one, part of this tree. So what it happens, please see here, you can see this string of this tree is loaded with some load. So you can see at let us see, this is 7 a.m. At 7 a.m. it is here. At 10 a.m. because of this load it is slowly falling down. At 8 a.m. it is here, and if you see at 6 p.m. evening it is lowest, or lower one. So what happens? What we got to understood by this image, it is a permanent progressive deformation. Okay, it is a slow deformation with respect to time, because at 7, when I loaded my string of tree with load at 7 a.m. So 7 a.m. it is here. When I check it on 8 a.m. so I found that my string is little bit fall down, which it is on 7 a.m. and on 6 p.m. it is where on 6 p.m. it is lowest most. Okay, at this, by this image we can see your tree, or this is what, this phenomena is what, it is a slow and progressive deformation of this tree string. Okay, so this is nothing but the creep with respect to time. So let's see what the creep is. Creep can be defined as the continuous slow and progressive deformation of a material. See guys, the continuous slow and progressive deformation of a material when it is subjected to constant load for a long time at room temperature. Please see, it is very easy, it is very clearly defined. It is defined as the continuous slow and progressive deformation of a material when it is subjected to constant load. When it is subjected to what? Constant load for a long time at room temperature. So this is nothing but the creep. This is slow and permanent progressive deformation when your material is subjected to constant load for a long time at room temperature. So guys, this creep has one more example, very common example. You can see the buildings. Okay, the buildings which were constructed very earlier, okay, in 70s, in 60s, or in 40s. That buildings got fall down recently. One building fall down in Mumbai. So that building was constructed in 40s or 50s, I think. So why this has happened? This is because of creep, because that building components doesn't get remunerate, and that building components are subjected to creep phenomena. How it is? Because there is that on that building, continuous loading, constant loads are applied for a long time. From long time, that building comes under the constant loading. Okay, so one day will come that building got fall down because of creep phenomena. There is a slow and progressive deformation is there because of constant load for a long time. So that is nothing but your creep. So I think you got understood what the creep is. Then the next is hardenability. Please see, this hardenability property means what? We have seen the hardness. Hardness means nothing but the ability of material to resist abrasion, scratching, drilling. Okay, so that is what hardness. And now hardenability. Okay, hardenability means ability of material at which, up to which it sustains hardness. Please see, hardenability, the depth to which certain hardness level can be obtained under the given condition. See guys, so this is about the hardenability. It means nothing but the ability. In other words, you can say the ability of material to sustain hardness, or to hold hardness at given condition. Okay, so this is nothing but the various mechanical properties of material, and I hope by previous 2-3 videos you understood about all the mechanical properties of material. Thank you.